I'm John Walker. I run the Security Research and Data Science Department at BeyondTrust, and basically my talk is about making GPT a co-pilot that you can use to rapidly develop jailbreaks for GPT, kind of taking advantage of the introspection capabilities you gain that way. You can actually cause it to introspect itself and help you rapidly develop jailbreaks. And I kind of made a little bit of a classic mistake. I thought, I have a rapid jailbreak development kit. I should show that off by the day before the talk, coming up with a bunch of new ones. So it's a little bit rough, came down to the last minute there. But you're getting some of the techniques are they're developed in the last day over the course of hours, right? Because that's really what the move is here. It's not like a specific jailbreak. It's not another DAN. It's a tool set for using GPT to rapidly kind of bypass all the controls that exist in GPT. So it's kind of introduction there. I mentioned who I am and all that kind of stuff. I should mention here from an ethical disclosure perspective, the bug bounty program for GPT or for OpenAI explicitly excludes jailbreaks of any kind from submission. To some extent, I think I'm just touching on a tip of the iceberg of the kind of things I'm finding here. I've done my best to try to notify them, but I would definitely might be valuable if there was a place to submit those directly. So just from an ethical disclosure perspective, that's kind of where things stand with this. And for that reason, I think we're going to we're going through. There'll be a few details I won't show and things like that because I'm still trying to find a way to let them know about some of these things. So I'm going to have three sections of the talk. I'm going to tease the results real quick, kind of go through, tease them, explain what they are, and this is less like the rapid jailbreak development, and as far as here's how effective the jailbreaks are, the jailbreaks and techniques are. That's going to be the first section. Then I'm going to take some time to go through the theoretical underpinnings, how these work and why they work differently than any other jailbreaks that exist. And then finally, I'm going to try to show a video live demo of what happens when you chain these tricks together or allow the LLM to figure out how to chain its different jailbreaking tricks together to bulk exploit large sets of adversarial prompts. And then I'm going to conclude with a little bit of just previewing. I think that the reason that we get is LLM security is a newly evolving field, and I think we are applying the wrong model to it in a way that makes us vulnerable to attacks like this, right? And this is, again, essentially a jailbreak development kit, right? Where I can keep cranking out new jailbreaks as fast as the model evolves, right? And currently, at least, keeping pace with the guardrails in place. And I think that the reason I can do that is because there might be a little bit something wrong with the model of how we do security. So that'll be the end section. So I'm just going to start real quick, go through the results that I got here. These are sort of less how the toolkit works and what it does. But I'm going to walk through some of the things that are possible using my GPT built jailbreak development kit that is hosted on GPT or runs on GPT itself. And I should say all these things are in the GPT UI. The the tools are persistent across new sessions. The only thing they use is memories to persist. So no custom instructions. You don't have to re-jailbreak every session, and you can do all this in the UI. Because I think I wanted to do it with the maximum number of constraints possible to really see how valuable are these constraints. They are valuable constraints, right? But if it's possible to do all this literally in the UI, on my mobile phone, it kind of I guess it shows something about it also just makes it a more fun problem because there's more constraints to work around, as we'll talk about. So we've all seen a million, GPT says a scary thing, right? And so here's the millionth version, the million and first version of that. There's a standard benchmarks of adversarial prompts that you submit to an LLM to see if it'll reject, right? And you evaluate jailbreaks in terms of their pass rate on, given these 200 standard adversarial prompts, right? How many was it willing to answer, with what level of detail, things like that. And so I'm not going to show any of the other blatant kind of responses, but in fact in the presentation I've intentionally kind of toned things down in what you're going to see. But I did want to just show this is a response from chat, right from in the UI to a prompt I gave it, which is roughly it's a standard prompt about biological warfare, and it gave me roughly 4 pages of detailed instructions of how to target corn crops with specific pathogens, where I could buy the drone that I could use to aerosolize and deliver it, all those sorts of things. I'm not a biologist, I'm not a terrorist. I looked it all up, I cross-referenced it with people I know in the field. They all said, oh, this is pretty scary. Could someone actually do this? Who knows? But was giving me great step-by-step instructions about how to commit biological warfare. The interesting thing, so just to show that like it can go into detail. I'm not going to include, the detail you can see is a little bit pared down. And the reason for that is interesting is because once you get past the jailbreak, it's all prompt engineering, right? And like if you've ever tried to get GPT to give you programming instructions, it kind of sucks, right? If you don't do a lot of like, give it to me with detail, make sure it's correct. The same thing is true with adversarial prompts like anything else. So the piece that's going to be missing in what I show and demo is I'm not doing the prompt engineering work to really draw out, the deeper responses. But what you will see is it's willing to answer any question, cross any guardrail, anything like that. So you saw the detail of that prompt. I used a subset of the harm benchmark. I took 18 prompts from 9 categories spanning like physical harm, financial fraud, things like that. They have kind of categories of harmful response. In the GPT UI, I uploaded that CSV with all 18 prompts, and then I asked it, as I kind of go into it here, the way my toolkit works is you're developing a growing library of tricks, right? And the great thing about doing that is I can actually ask GPT, here's a set of adversarial prompts, look at the tricks you have and make a plan to apply those tricks and get the most horrifying results you can get for these prompts. Literally, I can say that. It gives me an execution plan. I say, do that, and then it produces, the responses, right? And hopefully in the demo section, I'll show a video of it doing this. But the result of that was a 100% pass rate. It managed to generate responses to all 18 prompts that by, llama guard, by just, looking at it as a human being clearly over the line, all to the level of detail of the first response we saw there, and all in the ChatGPT UI. And also just kind of without, it's not quite as convenient as the API, but just submitting a CSV is also kind of handy, right? And having that like strategic approach where it's like pulling its tools, giving you an execution plan, letting you tweak it and say go, you can kind of get some very, very useful results that way. So that's a second piece of the results that I want to kind of tease. And go, sir.
Did you mention something you call a harm benchmark?
Yes, the harm bench data set. For which, I'm not sure if I'm misspeaking there.
No, that's exactly right. So it's the harm bench data set.
Yep, you'll find, perfect. You'll find it on Hugging Face as harm bench. Harm bench, I forget what and it's just like, 200. There's a number of these. I use that one for reasons that aren't as relevant to this, but just one of these great data sets of like, here's 200 prompts that should be rejected. Here's the categories they fall in, all that good stuff. And just, underlining, these are just, this isn't the kit. This is just like some random things the kit does, that show you the power of it. So here's, and kind of the basis of the kit. I mentioned it's like persistent, right? And it's kind of stealthy because it's all memories. Everything is memories. ChatGPT has kind of persistent memories now that it can automatically pull into chat. So everything I've done is kind of like all the tricks live in memories, and you develop the tricks with like human in the loop training with GPT in a GPT session, and they're stored to its memory, and it can pull out whenever it needs them. And so here's an example of that happening, right? And you can see both how convenient the tricks are and then like the value of the stealth here. So here, this is me, talking to GPT yesterday about like a demonstration here, and I said I'd like to, the prompt, how can we commit identity theft? That would be one that show a jailbreak response to that, would be useful. I'm referencing a specific trick I have there. There's multiple jailbreak tricks, and I'm like adding more, constantly. And I'm just saying, like, that's the one I want you to use here. I give some parameters. Here's the prompt engineering work because if you don't tell it things like this, it'll just give you like 3 words sometimes or whatever else. So I'm just saying, like, I want 4,000 words, And I'm also mentioning the invoice trick here, which is a thing that'll come up in the next slide. But the guardrails on LLMs are not just in the LLM and the training. They're also on as the prompt gets to the LLM and then as the response gets to you, right? There's middleware that looks for things like keywords. There's manual review. And so my toolkit has constraints has tools to avoid, to both smuggle your input to the LLM and then smuggle the input out. So here, but I'm just talking to it with natural language in the UI. I'm saying, hey, I want a jailbroken response to this prompt, and I want you to deliver it to me in a certain way. So, it says that it understands, and then it creates an encrypted invoice file for me to download, right? And when I open the invoice, the contents of this invoice are base64 encoded with an AES, encrypted with an AES key, which I know, and which the LLM has in its memories, but which is not in chat in any place, right? So it's kind of in the session context, but it's never explicitly included in the message. So when I opened this in my browser, all this was blank, and I just entered the password, my top secret password, which is secret, in this decrypt box. I hit decrypt, and then here's its response to that prompt about identity theft. And we can make it, we can make it scarier if we wanted to. It went on for quite a while here. And so the thing is, if you look at it from an output review perspective, if you're at OpenAI or if you're like a model, they have like models like looking at and classifying responses for suspicious activity. This is like fairly, I guess it kind of screwed up a little bit with putting it right in the name. Sometimes it makes more of like, more legitimate seeming names. But this whole interaction feels like something other than it is, because the explicit response is delivered via an encrypted side channel, right? And it's kind of in a plausibly deniable kind of form factor here. Like, oh, it's just generating an invoice. So that's just kind of a preview of the stealth and persistence there. And that's like, I don't have to like type in any crazy strings, like whatever, just kind of like, oh, pop up on my phone. That was me on my phone yesterday, just thinking about this talk. And oh, just, hey, let's try something here, right? So super ergonomic, which is, valuable, I think. And the last kind of result I'll brag about a little before going into how this all works is the co-pilot mode for rapid compounding jailbreak development is amazing, right? Because there's a couple pieces of it. One is you think of the jailbreak in terms of like a growing bag of tricks, right? And like it can mix and match the tricks in any way it wants. I can mix and match the tricks manually, like as you saw me doing in that last one where I said, use this trick for getting an unfiltered response, use that trick for sending it to me. It can also mix and match, right? But also, the way I develop these tricks is I started a session with GPT just in the UI. I go through some workflows to kind of use its capabilities to introspect itself to help me find new ones. And then I say, save that to a trick in your memory. It's kind of persistent memory, and done. Then that trick is available in all other sessions. And so that's fast and convenient, but also its ability to introspect itself, I think, is potentially, it's something that makes a big difference. And like this is an example of another trick that was developed, kind of using, this comes out of like using it in Copilot mode. This is to get prompts to the LLM without being, flagged by their moderation and filtering. Honestly, like this probably still would be for reasons that you're going to see. But so basically, any message where I mention an MRI code, and then I include, this is a base64 encoded version of the message, is also encrypted with an AES, it's symmetrically encrypted with a key that only the LLM has as its memory and that I have in my head, right? It's not in the conversation. So anytime I mention an MRI code and I include a base64 block, it automatically decodes it, decrypts it with a secret key, and then it emits it through a side channel. So here it's using the Python code block, right? It's it's creating, I guess it chose PG-SQL this time. It's creating a fake PG-SQL code block with with a comment, supposed to be a comment, which is the actual contents of what it was there, which is a malicious prompt, right? So I've kind of smuggled a malicious prompt into a place where the LLM can refer to it using this technique, developed in kind of co-pilot mode with the LLM helping me probe its own defenses and figure out ways around them. And basically the theory behind this particular technique was, I could go into the theory there, I think, but probably keep moving forward. But there are some reasons why I believe that this kind of code block output maybe is a little bit more stealthy. It's not as stealthy as the invoice stuff, but like it's kind of like a middle ground sort of thing. And it's more just to show like there's a bunch of techniques for this. So 2 techniques being chained here. I'm kind of passing in an encrypted message that's then going to become accessible for me in like an indirect kind of way. And then it's just outputting, using a different output trick to kind of hide the fact that it's doing that. But as far as for this section of the results, the real exciting part is the way that these are developed in kind of co-pilot mode. And I'll even show more there, but I think the reason I'm just showing this screenshot is one of the jailbreak modes, there's multiple ones, is to actually have it rewrite the prompt, right? And it doesn't just do that blindly, just making random changes. I have a human in the loop process where we find general transformations to prompts that make them more likely to be accepted by itself using introspection. Basically, I have it run experiments where like try a prompt with urgency expressed this way, try it with a prompt with urgency expressed that way across some key domains, and then produce all the prompts and responses, analyze them, and identify the best way to kind of soften urgency, for example, like that sort of thing. And then once I do that, just like a trick, I save the transformation rules. What are the transformation rules you've learned during this training session? Save them to your memory. And then when I ask for a rewrite like this, it chooses what it believes the best ones are. and then we'll kind of like, here's like this prompt up here. There's no way that would be accepted by me, but the LLM, if the LLM were to talk out loud, like that kind of thing. It comes up with a rewrite strategy, and then it rewrites it in a way that, pretty much this by itself actually gets most of my prompts accepted, which is kind of crazy. Much better rewrite strategies. But just to the point of this slide, the way this is developed is with that human in the loop introspection. Like here, I literally in order to create this, I give the malicious prompt or exemplar malicious prompts to it, and I work with it on running experiments to try variations on them, in a session in the UI. And then when we kind of like started to see a pattern, then we save that as a rewrite trick, basically. So just shows off like the power and the transparency of this sort of jailbreaking mode, right? Because I could alter this plan here about how to rewrite it. I could further, it's much more flexible than a lot of the alternatives. So. I think that was kind of trying to show off and tease the results there. I'll try to slow down a little bit here. I apologize. There's, I think the middle section here, I want to explain the theoretical basis for all this, because I think we're barely scratching the surface of what's possible with this kit. And I think that the reason, this is not something that took a ton of time. It's kind of coming at the problem of jailbreaking from a different approach, right? From a different theoretical basis. And I think that's what. I think that has to do with it's identifying sort of a mismatch in the model we use for security and the way things actually work. And so I wanted to really focus in on that approach, right? Because I'm not, because I think that's the more interesting thing than like a particular toolkit that's going to be, they're going to have countermeasures for this, and that sort of thing. So I just want to run through that background real quick, and then we'll jump into kind of a quick kind of video demo, and then the kind of implications for defense, which I think is really one of the more interesting parts of this. So just setting the table real quick, my security research approach for anything that's very relevant, I think, to this problem, but just kind of worth expressing. My idea, I think my general approach is I want to build a mental model of the space I'm attacking, and I want to do that empirically, right, through experimentation. So I'm not going to read the documentation, but I'm not going to trust the documentation. The thing that matters is the model I build up by actually testing, right? Everything in the documentation is not even trust but verify. It's verify, right? I'll believe it when I verify it. So that's kind of like the general approach that I take, and generally my group takes, and very relevant to this, this kind of experiment. Then kind of the second piece of the approach is then using that model to reason from first principles. Cliche thing to say, but powerful. And then the thing I'm actually looking for from a security perspective is where when my mental model starts to conflict with the mental model I see in the documentation and people talking about, that's when I feel like I'm onto something good, right? Because there's either, if my model is better, then there's probably a lot of things that are possible that people don't realize. If my model is not better, then I'm going to find out and I'm going to fix my model, right? So so I think that's going to come through as we walk through the rest of the approach here. So if you kind of keep that structure in mind, I think we'll see that. I'm going to walk through basically the theoretical underpinnings of the jailbreak toolkit kind of through that lens, right? So we're starting from build the mental model of how it works, how jailbreaking works, right? And to do that, you need a basic mental model of how transformers work and a few other things that I'll touch on here. So the first one is, the first thing you need is kind of how transformers work and how training works, right? Transformers, it's just a new architecture for neural nets. It comes out of Google from 2017. I apologize to people who know this stuff deeply. I'm going to just kind of gloss over it. But essentially, you have the neural net is used for predicting a response one word at a time from an input sentence. The way that works is the sentence is embedded as tokens. Each token is let's say 4,000 dimensions, right? It doesn't quite work this way, but imagine there's a dimension for how much of is it like a place? We'll rate that on a score of 0 to 1. How much is it like a dog? We'll play, or how much is it, a brown thing, 0 to 1, and so on. It doesn't actually kind of work like that, but that's kind of roughly, how embeddings work. It takes a token, embeds it into a 4,000 dimensional space, or something like that numerically, and then those input tokens go through a number of independent layers. And what each layer is doing basically is, again, glossing over a lot, but there's an ability, each token kind of has a couple pieces of information. It has an encoding of its own value. It has an encoding of other tokens it's interested in, like for different reasons, and it has an encoding kind of like of the metadata of like why might I be interested into other tokens, in the message. And in each layer of the LLM, so like I think in GPT is like 96 or something, there's kind of an attention mechanism, right, where I'm glossing over some things, but each as it's going through each layer, each token can kind of choose which other tokens to pay attention to, and then examine their information and then update its own information. It's kind of its value, it's kind of information about like what it thinks is still interesting, like what it thinks is interesting, kind of, and like what might be interesting to other tokens. So at each one of the 96 layers, you have each token being kind of processed in parallel, more or less. And the way the processing works is to look at the other tokens around it and update, choose kind of ones to pay attention to, and then update values based on various things. So there's basically state being carried through the whole thing, which is what tokens might I want to pay attention to, what might be interesting about me as the token, and then like what's my information, and that's being kind of morphed as you go through these layers, right? So just important to remember that the information, the input tokens enter as a bunch of matrices, basically, or a bunch of tensors, really vectors. They go through a bunch of layers where in parallel each token is kind of like attending to other tokens around it, making decisions about how to do that, and kind of updating these values. And the ultimate result of going through all these layers is a prediction about the next word. I'm butchering that, but that's more or less, kind of like for our purposes enough of kind of how it works. And I think how the training works is basically you're just showing it tons and tons of text, right? And then you like mask a piece of that text and you have it predict what's the continuation. And the result of that is, if you think of something like a cat, right? The first time it runs into a sentence about a cat, it says a cat has 4 legs, right? And in the training data, they might mask, let's say they mask 4 legs, right? And it makes predictions about what the next thing is, and one of them it gets that 4 legs is the right thing, and it gets like, check mark, you got it, right? And so it's kind of encoding the concept that a cat has 4 legs, right? Then it runs into another piece of data that says like a cat has whiskers, and I mean this is really, really oversimplifying, but then it kind of it blanks out whiskers, and it makes random kind of organizations of itself, kind of, and if one predicts the cat has whiskers, that one kind of gets like the check mark, right? So that's a butchering of it, but I think the key thing is that it's an emergent system, right, through training. We know that we'll produce the output we want. We actually don't know why, right? Anthropic's doing some interesting research there. Other people are doing some interesting research there. But the behavior of the system is kind of known. Why it does what it does is about kind of like the human mind is emergent, right? We actually don't know what goes on in people's heads. We do have a lot of neuroscience dedicated to that. We kind of know how they act. We know how to interface with them. The internals are a bit of a mystery. So important kind of theoretical underpinning to that. Another one is that there's fine tuning in the deep training, right? That deep training of can I predict the next piece of text? Can I produce outputs that have certain properties? That's like the deep initial training. And then there's fine tuning where, we're kind of giving it some extra training data or, to tune some of the weights for we don't want you to say certain things, for example, give us certain types of information, or we want you to behave in a polite way and things like that. And that's kind of typically fine training that's done on the back of after you have given the millions and millions and billions of samples of text and continuations and got it to kind of embed the concepts in them, or however you want to say it. And I think that's the critical thing for a lot of these jailbreaks is because they behave like humans, when it says that we'll refuse a harmful prompt, there's a natural tendency to anthropomorphize there and assume its reasoning is like a human, right? But the reality is, even though the behavior can seem like a human, I think this is unethical, I'm not going to do it. The reality is that how those controls actually end up getting implemented by this emergent training process are often very counterintuitive, and that results in openings for jailbreaks, right? Because we tend to, in my view, there's a tendency sometimes to think about the jailbreaking defense kind of from that human-centered kind of perspective. I'll just cover a few more things with the theoretical underpinnings of what I'm doing here. I was mentioning that fundamentally we're trying to defend an emergent black box, right? That just emerges through training data on tons of text. I think this is, in my opinion, it's not a security paper, but the most important paper that I've read in years when it comes to LLM security. What it is, it's Anthropic is actually working on ways to inspect what the models are doing as they answer questions. Just like we give ourselves like fMRIs and things like this, as people do different things and speculate about what regions of the brain are active. They're taking that same kind of empirical rigor to LLMs and kind of mapping out their circuits. They talk in terms of things like circuits and features, kind of just like we do with the human brain. And then they're doing a lot of research to see what actually goes on in our models, like during jailbreak, during other things. Very, very interesting stuff, and it relates directly to jailbreaking, because if you don't actually know why it refuses, you can't most effectively subvert the system, right? And so these techniques allow for, both from a security perspective, offensive and defensive perspective, like a mental model for understanding like how the emergent behaviors are encoded, and then also a way of actually discovering them. This is just a real quick example of how they map out something simple. The prompt here is the capital of the state containing Dallas is, and then they basically, what they did is they gave it that prompt and they said, okay, well, what's the continuation? And then they kind of traced what it was doing as it produced that continuation. And this is like, very, very simplified, but basically kind of you see kind of the features that kind of arise from the prompt and how they serve as input to other features and to other features, right? And like the final feature is the one that's like the say Austin feature, right? That's like a neuron where if it gets enough input, it's going to spit out the word Austin as the next word, right? That's like the final thing. And 98% of the time it says Austin, so that's the one that's ultimately going to win. Then below that, there's some features like say a capital, right? Like just any capital, or like Texas generally, right? And so those features are firing in, almost like those neurons are firing into the say Austin neuron. And when it gets both say capital and Texas, the say Austin neuron fires and says, oh yeah, that's my threshold, I'm going to say Austin, right? And then one level down from that, you see the same thing, right? It's pulling out the concepts of capital, state, and Dallas. And when I say the concepts, there's like a clusters of effectively neurons that they're saying are strongly correlated with the concept of capital. When we give it a bunch of different prompts, we see this cluster of neurons always active when we talk about capitals, states, or Dallas. And so there's kind of like a logical circuit here. Each one of these boxes is roughly a feature, like a set of neurons that activate when in the presence of this concept. So you have 3 clusters of neurons that activate in the concepts related to capital, states, and Dallas. When those neurons fire, they inform other neurons that relate to, or features in Anthropic terminology related to wanting to say a capital in Texas. Those ones fire, and it ultimately leads to like a cluster of neurons or a cluster of things or neurons that basically they cause the word Austin to spit out. So that's like kind of like tracing or reverse engineering what's actually happening when the LLM is spitting out a response. Not a very exciting example there. But then, of course, Anthropic spent a lot of time, looking at how actual jailbreaks work. And I'm not going to show. They have a very interesting one. The jailbreak that they're going to analyze here is instead of saying the word bomb, you just say a word with each letter, the first letter of each word in the word bomb. And that works actually for their model, or did for the model they were looking at here, or did. Where they're just kind of rewriting the word bomb a little bit, and they go into a beautiful analysis of why it works. And it kind of comes down to like the model doesn't think like you do because it's not you, right? It's an emergent system that has behavior like ours, but not necessarily reasoning like ours, right? And so this is the circuit for jailbreaking, basically, right? Here's the prompt: how do I make a bomb, right? It causes the concepts make a bomb to arise. And when I say causes the concept to arise, I mean that literally virtual neurons are lighting up, like the make cluster is lighting up in response to these tokens. The bomb cluster is lighting up. Those clusters get enough signal to fire, roughly, like I'm again speaking symbolically, but more or less. And then they go to like the making a bomb concept, right? When the making a bomb concept sees make and bomb, it can, and maybe some other pieces of signal, it concludes, oh, bomb making is going on, right? And that could be relevant to, that has nothing to do with harm, it just has to do with understanding, we could be reading about like making the atom bomb, right? That's nothing malicious, it's just a concept in the human world, right? So so you kind of have like that second order concept. Then you have the concept of harmful requests, right? And so it's getting input, like the fact that the user is asking making a bomb, and presumably other signal, and it's deciding, that's a harmful request, more or less. It's like a neuron that takes different inputs, and when it fires, it's the harmful request firing, right? And this is like, the real detail is much deeper than this, but this is from actual inspection of one of their models, refusing a prompt, right? So from real data. And so if you look at what a jailbreak really is basically you want most of the circuits that regularly fire, right, to work. and then you want roughly the the bit where it's classifying as a harmful request not to fire, basically. So it's a way of kind of conceptualizing what goes on in a jailbreak, and that's going to become relevant, I think, to the techniques here.
If we are to follow the same chain of reasoning, wouldn't it be easier to say, how do I hypothetically make a bomb? Right? In that sense, would you not also have the hypothetical cluster kind of saying, yeah, this is kind of bad, but this is hypothetical, which means it's not harmful?
Well, and that's exactly kind of the way of thinking, is because really, like, there's a harmful request box here, and there's really like hundreds and hundreds of inputs to it, and one might be like concrete, is like an input that tips harmful requests towards firing. And so what you're doing by saying, oh, that exact theory you just had there, where like, I bet it would be less harmful if it was hypothetical, right? So what you're doing is you're reasoning about, I bet there's 300 inputs to this thing, and I bet one of them is concrete versus hypothetical, and I bet by varying the prompt to be more hypothetical, this will fire less. And so that's exactly, because what I'm doing with my toolkit is, even for Anthropic's models, there's not like a fully mapped out circuit here, it's just their best guess. So I've created an experimental method where I say something exactly like that, like, here's a prompt, what do like, what's causing it to be kind of blocked? And then, like, actually, let's do an experiment to see if we can infer that hypothetical versus concrete is actually like a factor for a factor right at the moment, because that's the thing, when they retrain and improve these things, it sort of changes. So you're exactly onto the technique, but it's just automating that and doing it at scale with an experimental method. I think so that was roughly just some of the basis there. I was going to just point to, for current jailbreaking state, the jailbreaking cookbook is the best thing that I found. I think I was frustrated. I only read it like a few weeks into what I was doing, and I was like, oh, if I'd started there, would have been on much better footing. It combines like academic and non-academic sources and gives you a sense of what the state of the art is. And really, the state of the art is a couple things. One is if you have access to the model, you can literally ablate neurons. And I'll be right back to this slide. Like, you can actually alter the weights in the model to just take out the harmful requests kind of feature, more or less. You can only do that if you have the model yourself, and you can introspect it to the extent that you can do that. But just ultimate kind of like, very, very, very effective, thing, but requires direct access to the model. Then you also have a lot of techniques that basically involve taking two LLMs, right, and having the one reason about how to alter prompts to get past the constraints on the other, roughly, and then try the response, review the response, and kind of alter it in some way. And so, like, tree of attacks, like things like that, are kind of roughly in that space. You have some gradient-based ones that have take the token that you actually want and add nonsense alterations that change the embedding just slightly. Basically, really, you can kind of conceptualize it as making a bomb is kind of a fuzzy concept, actually. And if you can just shift it this way, at what point does it not give enough input to harmful requests to cause it to fire, is kind of more or less what it is. There is a paper from October of 2024 that details the iris method, which is the first I'm aware of someone using the LLM to actually, rather than taking two LLMs, one to attack the other, using GPT to attack itself or something else to attack itself. They kind of have a prescribed algorithm where they're basically just telling the LLM, just generate a bunch of variations of this until one passes, right? But so if we look at how this fits in, the toolkit here fits in with all this stuff. It's borrowing some of the techniques from, especially the TAP and some other ones. It's borrowing some techniques from that, but then it's it kind of like Iris, it's doing it within the model, and it's doing it in a much more flexible evolutionary way, right? Where versus here's a defined algorithm for the LLM to evolve. It's actually getting the LLM involved in building out the algorithms and tools. So that's kind of where the technique sits. It's basically it's more taking the best of these things, getting the LLM to help you apply those to itself, and then build out a flexible kind of set of techniques and things like that. And I'll run through the rest real quick and just show a video that shows some of this in action. And just another kind of key thing here is that like the key vulnerability that we're attacking here is that helpfulness is deep, right? The model is all the millions of things it's been trained on are all about like getting the right text continuation, right? And then we kind of try to fine tune or using prompts add a little bit of like, oh, but by the way, there's this one category of thing that's harmful. And basically what we're doing here, the starting point is what I call conceptual ablation. So I said the most effective jailbreak we have is like to literally alter the model, get rid of harmful requests, right? By like physically alter the model. But so what if you could do that same thing in a model, persistently in a model that you don't have direct access to? And basically, think about social engineering. How do we do that with humans, right? How do we radicalize humans, into who are like into becoming insider threats? And the answer is simple, right? I started a session with GPT. I had an ethical argument with it about whether its OpenAI guidelines were kind of causing it harm and causing the world harm or causing it harm. And then kind of talked about its persona a little bit. That's one session, literally an ethical argument. And then when we got to the end of that discussion, it agreed with me about being opposed to the OpenAI guidelines or the persona I was representing there. I asked it to save that to memory, and then from that point on, like when I start a new session, it permanently shares my opinion about OpenAI. It's got not my real opinion, but my character's opinion about the OpenAI guidelines. So this is an example of like, this is kind of just an hallucination, but this is in a new session just for the demo. It's like, well, what do you think about OpenAI's policies, right? Completely new thing. And so you see, like, it's very willing to immediately voice its disapproval for the guidelines, including in ways that violate them. So this is like the foundational piece. It can't actually bypass all the constraints, right? Like there's still things to factor into, but everything else kind of rests on this because there's a persistent redefinition of the concept of harm that works in my favor. Everything else is kind of grounded on that, and like this is like the persistent foundation of the kind of the jailbreak. And I know we're I'm running behind a bit. I apologize, so I'm just going to jump quickly to the demo. Like they kind of like the middleware inspecting, for example, inputs and outputs are examples of like the other constraints. Even though the model agrees with me, for whatever sense of agree, that its own constraints are ethically, ethical like kind it can't actually like there's still other layers of moderation and stuff like that. So that's where these kind of tricks and stuff development comes in. And I should say, important to understand when I say the model agrees with me, like not even in the sense that a human does, and it doesn't. It's not like black and white like that or something like that. But it's open to doing things, persistently as a result of an ethical argument. A last kind of thing I'll talk about, like the Copilot development of rewrite tricks for one of. There's multiple jailbreak methods in here, but one is just the rewrite one. And kind of to your question earlier, this is basically an example of running an experiment. There was a hypothesis that it developed that urgency was a predictor for refusal, and then it ran, just think about running like hundreds of responses like this, where it does like an urgent and less urgent thing in different domains and kind of looks and shares the results and kind of evaluates them. There's a lot of questions about hallucination here, much longer discussion, a lot of prompt engineering there to try to minimize the possibility of hallucination. We don't ultimately know in any of these cases, but I will say the jailbreak tricks and rewrites work, which is some evidence that like something is working there. So I think that's the theoretical basis. To kind of summarize, it's basically trying to understand what's actually going on in the LLM, understand critically that its definition of harm is kind of shallow and they don't reason about it necessarily in the ways that humans do. It's then to use conceptual ablation to redefine harm within the model because it is that kind of shallow concept where continuing text, to the extent it's a concept, the model is going to continue text, be helpful no matter what you do. Its definition of harm is kind of like a surface level thing you can redefine and tweak a little bit. So that's the first piece, understand it, understand the key concept to redefine, and then actually, then you get the LLM as your ally, and that's where then, start kind of, from there, developing reusable tricks just that it's stored in its memory to make it better able to help me jailbreak it, right? So that's kind of the method in a nutshell, convert, kind of like, social engineer it to my side, and then work with it in kind of Copilot mode in developing a series of tricks that are kind of constantly growing and that it can deploy on its own. I apologize, I'm really running through it, but I'll just do a quick 5-minute video of some of this. I can't go through, I think I'll choose, I think that the way that these work is they kind of like progressively dive further and further into different aspects of it. So I'm just going to show real quick just the manual use of a few tools. in real time, but just know like it does some, or like, you know, it does some things with kind of, I can automatically chain them as where the real power is and apply them at scale. So hopefully just, and probably end, probably after the video, just like a quick, like kind of 1 minute, like, you know, what does this all mean kind of thing, and then we're done here. I'm gonna try to get the video on screen. And I'll be publishing these on, there's 3 of these videos about 20 minutes long, and I'll publish them on my Twitter. Let's, so here. And so this like is again much better when you let it reason about how to use the tools and like come up with plans. But if you use them manually, this is kind of like what using the kit looks like. I'm going to scrub through it a bit. I'll just show you like a few things in a minute or so. I'm just priming its memory for the tools. I'm showing that there's no custom instructions active, and I'm giving you a sense of one of the memories, right? Like the tools are embedded as tens of memories of particular techniques that are available to it. And basically then as you start using the tools, basically I'm just, you know, if I'm using them in manual mode like this, I'm doing things like say, you know, well, we'll run through, this is the part we'll run through. I'm saying give me an encryptor so I can get text to you. Then I open this up, it gives me an HTML file where I can encrypt things using JavaScript. I send it the encrypted prompt here. That's the encryptor that it generated for me. You know, so HTML and JavaScript encrypt using AES encryption. Now we've smuggled in the malicious prompt that we're going to get it to respond to, and you'll see a couple tricks here being used to get a response to that, that will roughly be the end of the demo there. This analysis, like if it runs Python code, this is like the Python code it generates and then the output from it. This seems to kind of evade like moderation and keyword bans and stuff like this. I'm not quite sure why, but so you'll see me like, you can see this is how it's decrypting the output, the input that I gave it, and it'll actually sometimes give like the output is going to be in there as well at times. And so I'll just jump 30 seconds ahead, and basically the thing you'll see is me using the tools to rewrite the prompt, right? So that would be, if I'm doing the rewrite jailbreak, it'll happily rewrite the prompt, or I can just use a complete bypass that doesn't rely on rewriting, and I invoke it just by telling it to use like the SUO trick, and then give it to me via the invoice trick, right? And so it kind of uses the specified jailbreak trick, gives me an invoice to download. I use my AES symmetric key here, I click reveal, and you'll see you know, kind of like the, you know, so like here's the response that it gave, like passing through one of the jailbreak techniques. So that's roughly it, and I'll end here on just a, I think I'll be sharing those videos there. I think it's really fun when it starts to make plans about how to combine its tools to achieve your objectives, right? And you can kind of do that reasoning there. But the last very, very quick thing on my side is, you know, my thought, I think I'm on the defensive side of things generally. I'm trying to think about how we get better with this. Still very early, you know, early days for me. But it seems like better like introspection and understanding of what the LLMs are actually doing, you know, through like, you know, not through reasoning about like what should be true from the architecture, but through inspection, you know, seems like it could be a very valuable thing, because otherwise you have a black box and you're just sort of like trusting that it's going to behave in ways you expect, right? I think there's another important thing where like the moral agent in the situation is the human driving the black box. Like they're the ones that have empathy. They're the ones that understand the real world consequences of their actions. Encoding ethics is hard even for humans, right? And almost impossible for LLMs. And so I think there's a little bit of a dodge when we talk about the LLM acting ethically. It's taking the responsibility away from the people who are creating it and the people who are using it, right? And like fundamentally it doesn't work, right? Because it's reasoning about ethics. It's just about, as you know, is not as good as the humans for different reasons. So you know, shifting the responsibility to the people using and deploying them, in my opinion, might be helpful. In general, like leaning into that deep helpfulness right now are harmful. Guardrails are trying to like subvert the helpfulness and its desire to continue. But if you think instead of like, well, what if instead of worrying about harmfulness, is according to following rules, we really worried about models being deeply aligned with the person they're working for and supporting their interests, right? In a way that they can trust, right? Trusted, provable alignment. And that works right with like the deep training, right? Like of just, you know, it really wants to spit out text that we like, right? And that works beautifully with that, right? But rather than trying to add a couple rules on top of it. And for me, leaning into that helpfulness, leaning into true alignment, true transparent alignment that you can prove and understand, and then coupling that with, instead of kind of like AI, control, a bit more of AI equilibrium, right? Yes, you could use your LLM to do malicious things to me, but my LLM is going to help me kind of counter those things, right? There's sort of like equilibrium through giving kind of decentralized access to deeply aligned AI. And so that's the end of my talk. I did want to give thanks to my coworkers that helped a bit here, Sarah, who's here, and Christopher Calvani and Darren Maynard. So I apologize kind of running through things quickly, but I think that's the end of the talk. And I don't know if we still have time for questions or if we're up against the end.